10-second warning. 3, 2, 1, go. We're live. This is Retraice segment number 88 for Tuesday, December 20th, 2022, 10 p.m. Eastern, 7 p.m. Pacific. Retraice is about what's going on out there. The short answer to that is computer control. The long answer to that is natural, artificial, and strategic intelligence, and humanity, which is the best part. And Retraice is for outsiders, but we came to the conclusion that the computer control game is player-oriented, and outsiders are not players. So we're learning to play. Let's learn to play. Yesterday we played. We had some good times yesterday, I think. We hung out, right? Well, let's go to the tape, I think, is the best place to start because we ran into some problems. It started at about I think I said it was 102, 103, 20.
Calling the function.
Who's calling the function?
What's he doing? Multimap. Who calls? This was commented out.
Yeah, okay. So let's just get right into it. The first bug that we had was something seemed to be calling multimap, and we didn't really know quite what it was. And the second bug that we had was we were trying to print the default dict given the argument list. And okay, wait. If you're not with us, this is the December to Remember Math and Code event. We are preparing for our 6-month deep dive into AIMA4e, Artificial Intelligence Monitoring Approach, Russell Norvig 4th edition. We're going to do that January to June inclusive. This is specific codey stuff, okay? We're working on the multi-map function. We worked on it yesterday. We're going to finish it off today. Why? Because we want to get to the point where we can code what we need to code when we get into the good stuff. So we're not focused on the AI right now. We're focused on the Python or the math. If we're doing math today, we're not doing math. Okay. Yesterday, everything was going just fine until it wasn't. All right. I just wanted to land that plane. Let's keep going here. See what happens. Multi-map. Maybe it's because it's up there. Oh, okay. Here we go. All right. Let's just make sure we didn't. Does a bunch of garbage. Is it because, and I just noticed there at the bottom, we're getting weird behavior that we don't like because we're instantiating a map? Yes, it is. It is exactly that. So basically, not basically, we are instantiating a map. A map is a class, or instantiation of it is an object. Okay, let's go to our code here. This is going to be a little bit more sensical to follow through. Just starting from the top, we've done everything. We do imports. We're borrowing the code from the Python implementation on the AIMA official GitHub page. That's what all this stuff is, folded up, so it's not in our way, blah, 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 okay? Here's our map class. We've got the initialization here and a bunch of attributes and whatnot manipulated down below. Okay, the trouble came in when we thought we were not instantiating, or we thought we were not calling multi-map, okay? Because it wasn't in the later commands that we were running down below. Okay, we didn't have anything down here. Now this is from today, so this was not part of yesterday's code. And yet, there seemed to be behavior that suggested that multi-map was being called. Well, of course it's being called. Why do we even care about multi-map? Because it's part of defining the neighbors attribute, finding our neighbors, our next actions in our state space when we're running a search tree. What we had done inadvertently or unawares was, and let's go find it. So down here, whoops. That right there, tmap, was an instantiation of map. And if you instantiate a map, then what happens? Well, then multimap gets called right here. Okay? If multimap gets called, then some things start to happen. Then we get something called side effects. Why? What happens? Well, we give it an argument of pairs, okay? But our argument is not pairs. Our argument is links. Okay? Up here, nope. There, okay? That links right there is the argument when we instantiated a map as, a tmap was the name of our map, our object. we passed it our links. Now, what are our links? Just to review, our links, actually ours are up here. We borrowed them, but we do T-links, which are easy ones, or a simplified version. And where are our T-links? Oh, it's up here. So we give this argument when we instantiate the map, T-map. Oh, darn it. Gotta get in read only before terrible things happen. T-map, thank you. Right there, we'll get there. Okay, so look, we're giving it the argument of T-links, and T-links is this thing up here. T-link, go up to it. We're giving it this argument, okay? We're giving that to the map class, and the map class is passing it to multimap, okay? Just by instantiating a map as an object. Map is a class, T-maps, T-links, no, T-map was our instantiation of that class. We were executing multimap. What does that mean? That can't be good. Of course it can't be good. Not if you're having trouble with it, but it's all fun and games. Okay, so let's just ignore this thinger here because this is the new and improved run of it. We're not going to deal with that right now. What we were running yesterday, essentially, uncomment, we were running this, okay? So we were passing T-links here. By passing it to map, you pass it to multimap. Multimap, look at its indentation. Is there space here? There's no space here. Is indentation significant in Python? You're damn right. Are you crazy? Why would you even ask that question? What's wrong with you? Jeez, an inappropriate. That's not appropriate. Is what I meant to say. We passed an argument from our class, or we pass it to the class, and the class passed it to a function that is outside of the class. It is not a method. It is a standalone function. And what happens next? Well, look, I don't think this should happen. Okay, I've read things that suggest to me that we should have to type the word global in here somewhere to, like just before this pairs, so that it would manipulate a global variable. But you know, I don't know my Python. I'm not a good programmer. All I know is the behavior is clear. When T-links gets passed to multimap here, okay, and multimap does its thing. It takes, you know, it's in our case it's a dictionary. I think it could do this with a list of tuples or something, but we're passing it a dictionary. It's going to produce a dictionary. It's going to produce our dictionary of neighbors, which is our actions from whatever state we're in. And if that's kind of hard to follow, let me just do you a solid here. Here's AIMA4e, their homepage. This is our state space. Okay, we're starting from A, we want to get to B. When we're in the state A, our next actions, our actions available in state A are Z, S, and T. Okay, we can't jump to Fagarash from Arad. We can't jump from Arad to Bucharesti. Look at that pronunciation is, it's beautiful, right? Okay, eventually we're going to superimpose a search tree on our state space. Here's the first phase, the second phase, expanding nodes like we know what we're doing. Here's the code, the source code that we're working from. Most of this code is them. This is our GitHub if you need it, and all the other nodes that we've produced to get to this point. Brings us back to here. Okay, so we want multimap to produce those neighbors. Okay, those neighbors, ZST was it? Whatever it was, the neighbors of A. We need those so we can proceed with our algorithm or proceed with our implementation of the algorithm. So this multimap function is going to produce an output of neighbors. You give it the whole state space. Let's see, is links the state space? No, because it is part of the state space. Okay, this is the actions part of our state space. The structure comes from down here. We do the things that make things happen. Okay, so when the AIMA people instantiate a map called Romania, the first argument they give it is this dictionary of links. This is the actions, okay? And then the second argument they give it is a dictionary of states. And then together, these two arguments amount to a state space, okay? I think that's the correct way of saying it. Don't take that to the bank. what am I trying to do here? There we go. Okay, so we want those neighbors. We need those neighbors. This function does it. It sets result equal to default dict list, taking the argument list. I still don't quite understand. I understand the behavior of this function, but I don't know what, like default dict comes from an import from collections, and list creates a list object out of whatever you give it. I don't know. This one I'm still not there yet. I can't. I should have. Maybe we'll investigate that in a few minutes here. Okay, and then for key value in pairs, and pairs is for us our t-lengths argument. Or I'm sorry, our links. Yeah, ours is t-lengths, but they're in their class. Oops, get out of there. Okay, we'll do that, and we'll save, and then we'll get read only. You want to take the result. Oh, default dict is empty. That's the other thing. This is an empty dictionary. I don't know why it needs to take list, though. That's the only thing I don't understand. List creates a list of objects. I don't know. I don't understand the list part. I don't. I don't know. Okay, but anyway, into that blank dictionary, which is now called result. Okay, so default dict with the argument list is set equal to result. Then we're going to append a key value pair for every key and value in pairs. Okay, so that's what this little for loop does. And then once we're done, we return the result. Now we were running that, and we were getting a bunch of blank default dicts, and then we were trying to get we were trying to reproduce behavior that we had already, which had already looked good, which was the changed version of our links. So we were inputting our links that becomes pairs in that. This is convoluted. I'm saying this terribly. We were giving it an argument in this form. Our t-lengths was A to Z, 75 miles, A to S, 140 miles, A to T, 118 miles, yo to mama, 90 miles, and mama to dad, 91 miles, okay? We were giving it that, and we were getting back a really like truncated version of that, or certainly not the expanded forward-backward version of it that we want. So we want a forward-backward version of that, which is achieved by this little compound statement here. Because we're not using a directed algorithm. We don't want to direct our algorithm. And gosh, it's much easier to just play the tape than it is to describe it. Let's see. Let's just comment region. Actually, this is too. Yeah, so this is where I'm investigating the empty. I guess I have to explain this bug first because it came first in time. So this default dict class being empty thing, let's see, where does it start? Is it? Oh, because I put print. No, so when it defines these, no, you shouldn't. I'm defining the function. I'm not calling the function. Who's calling the function? Multimap. Who calls? You just said it. You just said it, dude. You just said it. Multimap calls the function. Okay. No, map calls the function. Instantiation tmap calls the function. Multimap. Maybe it's because it's up there. Oh, okay, here we go. All right, let's just make sure we didn't. Where is the? There it is. Look. All this nonsense. This problem that came before our 102.20 problem was because I was printing the damn default dict list instead of the result. Okay, so here, okay, the right way to do it I will show you, but I didn't. Did I preserve the wrong way? Of course I preserved the wrong way. Let's look at the wrong way to do it. Let's look at the thing that, where is it? Okay, Re87, and This is genius. Who invented computers? These are really nice. All right, the wrong way to print that thing that I was printing. Did I comment it out, dude? Don't do that. Like here, it's this, but I commented it out, so it's not syntax highlighted. Anyway, you're gonna have to deal with this. All right. Multimap is our function, and you're setting result equal to default dict, and then I go, okay, let's print default dict. Why, dude? Why? Why are you doing that? Why are you doing that? Okay, you just said you wanted to see what was in default dict. Nobody's updating default dict. You weren't even paying attention. I'm surprised at you. So I start printing default dict. We set it equal to result. Why are you printing this? Why are you printing this? You should be printing result. Blah, blah, blah. Result, append the key value. Oh, print this. Some of us commented out because I'm troubleshooting. And then it returns the result, and the result looks like something, but my print looks like nothing because result was the thing the variable getting updated, and we can confirm that very shortly here. Actually, I think I did it in the... Where did I do this already? Actually, no, that's the... Yeah, okay. Let's have a look. So if we... Let me just comment this out. I hope that makes sense. Basically, instead of... I wanted to examine this multi-map step by step, so I put some print stuff in there. This is the original. You're not looking at the print stuff that we were just looking at. But I started printing default dict, and what I should have been printing was result. Okay, that's what I wanted to see get updated in the for loop. All right, let's see what it looks like done properly. Comment region. No, you're in read only. Now comment region. Nope, you blew it. You fail it, bro. You fail it. Now you succeed. Okay. This big pile of snot. Okay, look, let's see if you can see it. Yeah, you can see the whole thing. So I'm just printing the crap out of this now so that we can look at the behavior and it's easy to understand and all this stuff. But most of this is just garbage, me printing stuff for debugging purposes. The main thing that we care about is we want to see in this for loop, okay, and then before and after this for loop, what happens to result, not what happens to default dict with argument list, what happens to result. So let's have a look. Let's give ourselves some space and let's make sure we're saved. And now let's run this file and let's have a look. Here's what happens, okay? So we go up and we start, we just ran from here, okay? This is when we executed the command or called Python and gave it the argument. Printing multi-map steps in detail. Here we are before the loop. Okay, what is the ID and what is the content of the variable result? The ID is that. And actually, can I copy that? Yep. Okay. So if we, whoops, no, not reverse search. This reverse search. Can I yank that? Yes. Good. Okay. So that ID. Nope. I'm not slick. I thought I was slick. Oh, I got to do reverse. Damn it. Okay. Well, I guess I have to leave it down there when I'm doing it. So there's the first one that we started with. The ID of this is like a unique integer that's assigned to an object in memory in Python. So the ID built-in function will throw back that unique integer, and then we'll be able to keep track of what we're dealing with, even if two things have the same name, like result. They're not necessarily the same object in memory. We could, I think, what gets us the memory address? I don't know, but this is the way I see people doing it. So this is one way of, keeping track of your object without worrying that you have two things with the same name. So we can see now that we're in the loop, our object, our 016, ending in 016 object, in the first stage of the loop. So it starts out, it's got nothing in it. Okay, it's a list and it's an empty dictionary. Why isn't it called a dict? I don't know, because I don't know Python or programming. Okay, now we're into the loop. And the same object now has A colon Z. And what that is there, what that AZ is for state A, it's one of the available actions in our state space. Okay? And then we go to the next one, and now we've appended another available action, S. Okay, and then we do another one, ZST. Okay, so now we got that's the T is the last one, so now we got a total of ZST. What does that mean? ZST. Does that sound familiar? We're in state A, and now our available actions are ZST. Wonderful. Took you long enough. Okay, what else happens? Well, we're in loop. Why is it not looping? or doing what I tell. There we go. We're in the fourth cycle through the loop. Now what do we have? Yo mama. Yo, if you're in the yo state, you can get to mama from there. Okay, that's good to know. Let's go to state loop number 5. Okay, oh, look at this too. If you're in the mama state, you can get to the dada state. Look at that. That's excellent. Or let's say, I shouldn't say that you can get to the state. That's the action you can take. And then if you take that action, our transition model will tell you that you are in the dada state. But it doesn't have to be that simple, but ours is, thankfully. Finally, outside of the loop, what are we going to do? We're going to return the content of result. It's the same thing we just looked at in the 5th cycle through the loop. It's A can get to ZST, yo can get to mama, and mama can get to dada, right? Great. What does that mean? Well, we've got part of what we need. So we are not in a directed state space, or we're using a directed algorithm, which means we can go this way and that way. And the actions available going from yo to mama are the mirror image of the actions available going from mama to yo. Now, how do we get that? Well, we've already done it. It's not super complicated. It happens up here in the instantiation of a map. Okay, it's this thing here. It's this links vertex 1, comma vertex 2 equals the entry vertex. Sorry, I say it. I don't know why they put it in backwards. Oh yeah, because they're the V2 V1 is the thing they're creating, and they're setting it equal to, or they're setting the item, or the item value, which is the miles, and I think they're also creating the V2 V1 entry and making it equal to that. We'd have to do a bit more probing of that to see exactly how it behaves, but that's the general idea. So what we're going to want when we instantiate a map and multi-map runs and we're not dealing with a directed graph situation is we're going to want that symmetry. We're going to want to be able to go from yo to mama and back from mama to yo, and we're going to want the distance to be the same so that we don't look crazy. Okay, so that's all this stuff. That sort of resolves our failure to print that result, to print the stages in that for loop, because this is what we wanted, and what we were getting was a bunch of nonsense. But now we don't have nonsense. Now we have sense, just plain old sense. And then I saved the output here as well, if you're so inclined, in the source, okay, as comments. All right, now what? Going back to the thing that we thought we were working on first and foremost. This is how I prove that the cause, the side effects cause of the other problem. All right, let's get out of that, and then we do that, and then uncomment. Okay, so now let's hide some everything so we can concentrate. I can't concentrate right now, not with all this garbage in my face. We'll hide all this garbage and clean out any other garbage. Sometimes I feel like I might need things, and so I leave them unhidden. So anyway, I preserve this good working version of multi-map, but our version is very verbose, so we use that today, but we won't use that in the future. We'll use the good working version. Okay, so what are we doing here now? We're going to instantiate a map. That instantiation is going to involve a calling to the function multi-map, which is going to change one of the arguments that we use to instantiate the map. It's going to change that links, okay? And it does. But the reason we didn't, okay, it's two bugs at once, and I'm jumping back and forth between them. The reason that we didn't have the forward-backward version of the dictionary in what we were just doing a second ago is because we weren't instantiating any maps. If you instantiate a map, if you create tmap, then you give the argument tlinks and tlocations, okay, you're executing that class map. Executing that class does several things, but the things we care about, the things that affect our lives and subtract minutes from them are first this this conditional and for loop, which creates a mirror image of the dictionary, which I'll show you in a second. And then the thing we just talked about, multimap, which calls so when multimap receives the links, it's already been modified by the directed compound statement. So when it sends links sends this down to as to multimap calls it pairs, then that stuff that we just looked at happens. It's weird, I can't do that. All this stuff happens, and so then we're going to have a changed links as our final output, as we're going to see now. So just think of it, just only think in terms of what we're doing right here, okay? Oh, did I hide too much? I did hide too much. No, I didn't. That's good. Tmap. Oh, I did. Gotta do a little bit less right here. Okay, this is what we need. Okay, these. Oh yeah, I gotta uncomment them. Okay, and uncomment key bindings are too time consuming. Okay, so and actually just ignore these because no, we need T locations, but we need. Okay, so we'll do that. So these are the only things we're doing. Okay, other than using the class above and the function that class calls when you instantiate an object, multimap, the class map and the standalone function multimap. All we're doing is defining this dictionary tlinks. Then we're defining this dictionary tlocations, test links, test locations. We're going to print the ID of tlinks. We're going to print tlinks itself, so we can see what state it's in before we instantiate the map. Then we're going to instantiate the map tmap. We're going to give it tlinks and tlocations because you need to give it tlocations for it to work. And I think you do, and you definitely should. And then we're going to print tlinks again, make sure we're dealing with the same memory object, and then we're going to see why is it modified. Okay, I hope it is, because otherwise I'm going to look slick in the bad way. Shall we do it? Shall we do it? Are you ready? I'm nervous. Here we go. Bang. Okay. So far, so what do we do? Final result ID return. Oh, did it do all this other crap? No. We don't want to do that. We don't want to do that. Hang on, people. Hang on. Everybody just calm down, relax. We do not want to do the long, chatty version because that's just going to clutter our output. Okay, so we're going to comment region, and of course, that. Now we do that, and now we have to uncomment the clean version that's not so chatty. And uncomment. Okay, now let's do that one more time. Please just do what I intended. Yes, that looks like what I want. It looks like what I want. Let's see if it is what I want. So, damn it. Cluttered my screen. Okay. So, first, our ID. Let's copy that, and then we're just going to confirm that, whoops, what did I do? Okay. Reverse search and yank. Look at that, okay? So the ID is the same. The ID of the object, and it's the ID of tlinks, is the same. So we're dealing with the same thing, but look, if we print that thing, the first time, it's just A to Z 75, A to S, A to T, yo to mama, mama to dada, okay? But second time we print it, look at that. It's twice as long. Isn't that twice as long? Now, what is this last thing did we do? Why did it print default dict? Did I tell it to do that? Print tlinks. Why is it doing that? Oh, I don't know. Let's see. Default. No. Return result. But it's returning it to the map class, so we shouldn't be seeing that. This didn't happen before. It's almost as if it's my fault. But that can't be. What are we doing here? What am I seeing here? I am seeing... It looks like I'm printing the damn T-links again. What I'm not sure about here is why this. I don't remember that being there the last time when I did this afternoon. Okay, these things make sense to me. Okay, we've got basically the T-links before and after instantiating the map. What is the map doing? No, what does instantiating the map print the original T-links? It shouldn't, but I've done a lot of funny things to this code. Oh, I don't know what's down. There's nothing down here. Oh, whoop! Don't do that. Okay, it's not down there. Damn it. Print ID, print T-links. Does printing T-links doesn't have both, does it? T locations, for Pete's sake. Is there something in the... I don't know why it's doing that. It shouldn't do that. Print the ID, print the T-links. Instantiate the map, print the ID, print the T-links. Why? Why this? What am I looking at here? We gotta run experiments. We gotta isolate the problem. All right. Let's just not do the second part. Okay. Still doing it. No, what is that? That's okay. So that's that same messy last line. Okay, good. So we're not causing it there. Let's see if just instantiating the map does it. Yes, it does. Ooh. Oh, that's interesting. So just instantiating the map prints the but why would it do that? There can't be. See, this is just I've tried to preserve too much work here, and now it's becoming what is it? It's spaghetti code. Let's see. The only damn thing I'm doing down here is that. Oh, damn it! I didn't comment out line 312. Everybody calm down. Okay. I didn't comment out line 12. That's what you get. That's what you get, man, for hiding stuff and acting like you can just hide all your problems and they're not going to come back and haunt you. Well, I'm going to start doing it again because I never learn. Comment. That's the only stuff we did, right? Can we please get the intended behavior? And that's it. Goodness. Okay. Now we have the original is this. Okay, that's the ID is the same for both. The original T-links dictionary is just as we put it in there. Okay. T-links right here. A to Z, A to S, A to T, yo to mama, mama to dada, all the while giving us distances. A to Z, A to S, A to T, yo to mama, mama to dada. But how do we get back from dada to mama? How do we get back from mama to yo? And never the twain shall meet the world of yo mama, dada, and AZST because there's no links between them. There's no way to get to these two. These are islands in our state space. But this second dictionary is the undirected and symmetrical. I guess you'd say it's symmetrical. It's definitely symmetrical in a certain kind of symmetry to it. Okay, so now that we've proven that we understand the problems we were having yesterday, we can stop having those problems. I'm going to call this out because this is just not clear to me, Kill Yank, that this is a little space where I want to do spacey things. There we go. And now let's comment it out. Comment region. And these are our test things, but I'm not really ready to go work on those now. This is all of the things that we've done and are no longer doing. And how many things do we really need to see at once? Is it this many? I don't think it's that many. And this is all similarly verbose, no longer welcome in our little world. Ugh, that's not good. I don't want that. Go to the bottom. I want to look at the maps. So I'm going to now bring us back down to Earth and start at the top. First thing we did is a bunch of imports, not just that one, all these imports, okay? But this is the only one we're using so far, is from collections default dict. Then we define the class problem. Then we define the class node. Then we define the function expand node. Then we started working on best first search, and that's our ultimate destination and goal here. But most of the time we're just spending trying to figure out problem, okay? Then we instantiated the route problem subclass of problem. That's all this fun stuff, which corresponds to these specifics in Retraice notes, which come from AIMA4e. We need a state space. We need an initial state, a goal state, actions, or an action function that takes a state and returns a finite set of actions that can be executed in state. That's what our neighbors was. That's what multimap does. It gives us the actions at state, actions available at state. The transition model, which is the result that takes the action, takes the state and the action and returns the state prime. In our case, it's like the same dictionary as actions, because the way we represent actions in this particular implementation is just the name of the place you would go, which is our new state. We need an action cost function. We got a little bit of that going in the mileage, but we haven't really dealt with that yet. Anyway, all that corresponds to the specific implementation here of route problem. And there's some stuff I've hidden here because we're not doing heuristic search. Then we had to come up with a state space. And that's what our map class is. So our map class has to take a few arguments. You at least need actions, which are the links in our case, links in our case, and then locations, which are the states of the state space. So state space plus actions or state list or dictionary plus actions available equals state space directed. We're not dealing with that right now, but ours is not directed. And then it's going to do all kinds of fun stuff to the arguments that we give it, so that we have things like distances attribute, neighbors, which are our actions attribute, and locations. I don't remember what we're going to do with that. Multimap is called for the neighbors here to get the neighbors, and it does the neighbors are the map class has already manipulated our links to make it twice as long and symmetrical, and multimap is going to take that version of links, and it's going to return key value pairs, and it's going to take multimap does. It's going to return one state. For each state, it's going to return the actions available from the links, from the original links. And that's that for loop. And then it's going to return that. And then down here, we're just doing tests to figure this whole thing out. And then eventually, not eventually, but pretty soon actually, we're going to, uncomment. Oh, come on, I did that. It doesn't always work, people. It doesn't always work knowing what to do. Undamn comment, you bastard. Oh man, this is my nightmare. Why? It's not read only. Okay, it is. It's not, it's user error. Okay. Then we're going to instantiate the Romania map that's going to have the two big arguments. First, dictionary of actions, which is the from state to state, and the mileage, or the cost, I think is what we're going to end up calling it. And then the locations, the states themselves. And then we've got down here a bunch of actual instantiations of problem, not of map, but of problem, the problem class, which means get from A to A, or get from A to B, or get from N to L, and use And by get to, we mean do it in the map of Romania. Okay? Got it? We're getting there. We're getting there. It's all fun and games. We got to just keep going through the rest of this, the route problem, and in particular the map class, to make sure we understand this last attribute locations. And also, the distances. I don't think we've like really looked at that yet. But anyway, more to come. This has been a Retrace segment number 88 for Tuesday, December 20th, 2022. And it'll be the same time tomorrow, 10 p.m., 7 p.m. Pacific. And all the notes will be on our website or in this podcast feed or in the YouTube comments, blah, blah, blah. That's it. Signing off.